Hello friends, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. B.R. Wadekar from Matoshi College of Engineering and Research Center, Nasik. As we are aware, in last lecture, we have discussed about multiple access. Then what is multiple access? Then what are the types of multiple access? As like your random access method, your controlled access method, and channelization. Then we have seen that what are the subtypes of it. In random access technique, in that method, we have seen about Aloha, CSMA, CSMA CD, CSMA CA. In controlled access techniques, again there are subtypes as like your reservation, polling, and in your channelization, FDMA, TDMA, and CDMA. And if you remember guys, in last lecture, we discussed about random access techniques, few of its methods, as like your Aloha we have seen. Although Aloha, it is not in your syllabus, but it was a simple, protocol. That's why we discuss about it. And then we studied CSMA, that is carrier sense multiple access. In that we have seen the three methods: one persistent method, non-persistent method, and p-persistent method. Then we have solved one numerical on CSMA. Today, we are going to discuss about the random access technique, that is CSMA CD. It means collision detection. And next random access technique we are going to see, it is your CSMA CA, that is collision avoidance. So let's start, students, with CSMA, your CD. Basically, guys, before starting actual flow diagram of your CSMA CD, I want to discuss a few differences between Aloha and about CSMA CD. Guys, the first difference, is that addition of persistent methods. In Aloha, these persistent methods were absent. So this is the first difference. As the name suggests, it is a carrier sense. It means we need to sense the channel before we start sending the frame by using one of these persistent methods, that is one persistence, non-persistence, or p-persistent. So this is the extra block over here. And the second difference is the frame transmission, guys. In Aloha, we first transmit the entire frame and then we wait for the acknowledgement, But in CSMA CD, guys, the transmission and the collision, these detection are continuous process. See this loop. Transmission and collision detection are in continuous process. We don't send the entire frame and then we look for a collision. The station transmits and receives continuously and simultaneously using different ports. So we are going to use a loop over here in order to show it as a continuous process. And also, guys, we are constantly, monitor in order to detect one of the two conditions. What are the two conditions? That either this transmission, it has been done or it is finished, or collision being detected. So this two process is continuously, simultaneously, it goes on. And either event it happens, it means either transmission done or collision detected, we are going to stop the transmission. And suppose if we are going to coming out of this loop and it doesn't have detected any collision, then we can say that transmission is complete or it is a success. It means the entire frame is being transmitted. And if it is not so, then collision it has been detected. So let's start, guys. So basically, this is the flow chart. A station which has a frame to send, it is going to initialize first. So K, it is nothing but a variable which shows your number of attempts. That number of attempts it is going to try to send the frame. So initially K is equal to 0, right? So now, as in our previous lecture, we have seen those persistence methods. So we are going to use that one of the persistent methods, that could be one persistence, non-persistence, or peep persistence. So after applying this method, now the next we are going to send the frame. So as I already told, we are going to monitor both. Is being transmission done? If it is no, transmit is not being done, then you are going to transmit and receive, because you are going to receive the acknowledgement for the same. And even the collision it is not being detected, then also it means carrier, that medium, it is a free, no collision it is detected, so continue to transmit and receive. So this loop it would continue. But suppose a transmission it is being done, the transmission it is being done, and during that transmission is collision detected. If it tells no, then your transmission is success, it is complete. But if the collision it is detected, we are going to use this loop. So this is for transmission done. Or either case, second case, if while transmission the collision it has been detected, if it is yes, then still we are going to perform the same process. That is, if transmission is not being, while transmitting, collision it has been detected, the transmission it is not successful, then we are going to send a jamming signal. Jamming signal, so that other stations would come to know that collision it has been detected. And since we have started with K equal to 0, so now second time, it's a second time now. So we are going to increment the number of attempts, that is K equal to K plus 1. So it would 0 plus 1, that is 1. Then we are going to see, because finally there is a limit for this K. So suppose K max it has been 15. As we know 1 is greater than 15, then no. Then continue your process. If K, suppose it is more than, greater than 15, then you have to abort the transmission. You have to attempt it next time. But suppose the number of attempts it is less than the maximum attempts, then what we are going to do it, we are going to again choose a random number, that is R, which is between what, 0 and 2 raised to K minus 1. What is K? It is number of attempts. So after choosing this random variable, then we have to wait. That station needs to wait for a random amount of time, that is denoted by TB, which is called what? Back of time. And this back of time, it is calculated by multiplying this random number with your propagation time or your frame transmission time. TP is denoted by your propagation time, and FR, that is your average time for a frame. So after waiting this time, that is back of time, again we are going to apply this one of the persistent methods. And we are going to continue this process whether the transmission done or collision being detected like this one. So in this manner, your CSMA CD, it works. Now, energy level during this transmission, we can say that energy of, the level of your energy in a channel, it can have three values. It could be your zero, normal, or abnormal. Because at zero level, guys, see if this is the energy with respect to time. So idle, you can see that when the energy it is a zero, it means what? The channel it is idle, no stations are going to send the frame. This is the first case. Second is that when the energy level it is a normal in the sense when the station has successfully captured the channel and it is transmitting the frame, so which is denoted which is shown by this blue color. It means the station is going to send the frame, and during that one the energy level of your carrier, it is denoted by it has a normal value. So now at the abnormal value, guys, it means when there is a collision, the energy level, it is almost twice the normal level. And when the station that has a frame to send, or it is going to sending a frame, needs to monitor this energy level, guys, to determine whether your channel is idle or it is busy or it is in what? Collision mode. So hope so, guys, you understood about your CSMA CD and how we are going to detect, how stations came to know that collision it is being detected or not. By what? By observing this energy level of your carrier. And the throughput of CSMA CD, it is always greater than that of your what? Pure or slotted aloha. Now the next method that we are going to see, it is your CSMA CA, that is carrier sense multiple access collision avoidance. Earlier we have seen, guys, collision detection. It means after the detection. But in CSMA CA we are going to try to avoid the collision. This is the difference between your CSMA CD and CSMA CA. So in this case, how we are going to avoid the collision, guys? So basically we are going to avoid the collision by using three strategies. Now what are those strategies? First, it is called your IFS, that is interframe space. First. Second, guys, it is your contention window. And the third, it is your acknowledgement. So, first, the collisions, are avoided by stopping the transmission, even if the channel, is found idle. So when an idle channel is found, the station unit is not going to send immediately. It waits for a period of a time which is called IFS, that is interframe space. Because why we are going to do it, guys, even though the channel may appear idle when it is sensed, a distant station, a long distance station may have already started transmitting. And it may happen that distant station signal has not yet reached this station. So IFS time, it is allows the front of the transmitted signal by the distant station to reach this station. And after waiting this IFS time, If the channel is still idle, then station can send its frame. But it still needs to wait a time, guys, which is equal to what your contention window. And IFS variable, the IFS value, it is a variable, because it can also be used to show the prioritize the stations or the frame types. For example, if you have a shorter IFS, it means it has a highest priority. It means you have to wait for a short duration, right? Now, about the contention window. What is this contention window? It is an amount of time which is divided into slots. See, you can see that the slots are there. A station that is ready to send, it is going to choose a random number of slots as its what? As its wait time. And the number of slots in the window, it changes according to what? This binary exponential backoff strategy. This means it is set to one slot the first time, and then it is going to double each time the station can't detect an idle channel after this IFS time, which is almost similar to P persistent method. The station needs to sense the channel after each time slot. And if the station finds that channel it is a busy, then it is not going to restart the process. It just stops the timer and restarts it when the channel it is get free. And the third that we called it is acknowledgement. The data may be corrupted during transmission. So the positive acknowledgement and the timeout timer, it can help. It can provide you the guarantee that the receiver has received the frame. So, as I already told, that is in CSMA, the IFS, it can also be used to define the priority of a station. If station finds the channel busy, it doesn't restart the timer of the contention window, it stops the timer and restarts it when the channel becomes free, idle. Now let's understand this, flow chart. So first, as we know, that K, it is nothing but your number of attempts. So initial we are going to start K equal to 0. Now it is going to sense the channel. If the channel it is not idle, it is a busy, then again it is going to go to the closed room. Again it is going to continuously check the channel. As in previous figure we have seen, it is going continuously, it is going to sense it. From that contention window also we can try to explain it, that it is going to continuously sense the medium. If it finds idle, then it needs to wait for this IFS time. Again, after IFS, it needs to choose a random number of this, a slot. And then it is after successfully, waiting back of time, can send the frame. So this same example, I am going to explain it through this flow chart. So if the channel it is idle, then as I already told, it needs to wait for this interframe space IFS time. And if after this IFS time, if the channel it is idle, then it is going to choose that a random number, that is R, which is going to represent the slot, number of slots, which is equal to 0 and 2 raised to k minus 1 in between this one. Because the size of this contention window, it is a 2 raised to k minus 1, and k, it is nothing but your number of attempts. So after choosing that R, it needs to wait for that R slots, that is for that particular duration. After that, it is going to send the frame. But before that also, initially guys, it is not going to send the data frame. It is going to send the RTS frame, that is request to send. What is it? Request to send. And then it is going to start the timer and it is going to wait for that timeout period. If from that receiver, if the acknowledgement it has been received, that is a clear to send. RTS and CTS, these are the the frames which is used before actually transmitting your data. So if acknowledgement, that is a CTS, clear to send, yes, you can clear it, you can send it now, then we can say yes, acknowledgement it is being received. After this one, we are going to send the actual frame, and every time we are going to set a timer. Within that timer, if the acknowledgement is not coming, it means somewhere your data it has been destroyed. It may be due to collision or so corruption. So after that one, if it doesn't receive the acknowledgement, then it is going to increment the value of k, that is k equal to k plus 1. And as we know that we have given the limit to this k, that is k max, it could be 15. And if the actual number of attempts it is greater than that of your maximum attempt, then we are going to abort the transmission. We are not going to participate in sending the frame. But if the actual value of k it is less than that of your k max, then we are again going to participate in this process and we are continuously going to check the channel whether it is idle or not. So every time, if it is continuously, it is going to check, sense the channel. And after that, if it finds the channel idle, then it is going to wait for IFS. After waiting IFS, again it is going to sense the channel. If it finds the idle, then as I already told that it is going to pick up the number of slots from that contention window and it is going to wait for that R slots. And after waiting that R slot, it is going to send the frame and it is going to start the timer. If before that timeout period acknowledgement it has been received, it means your transmission is success. It is being completely finished. So hope so guys, you understood CSMA CA and you got the difference between your CSMA CD and CSMA CA. So it is the most important from your examination point of view, because either your CSMA CA or CSMA CD it could be asked. And simply CSMA it is being asked, so you can explain the persistent methods. So it's all about our today's lecture, students. As I already told, few of the techniques that we discussed in your previous lecture, that is LO and CSMA, and remaining two techniques we have studied in this lecture. So this is your assignment second of your third module. So you need to solve this assignment and you need to submit it. In next module guys, we are going to discuss about controlled access techniques. Up till now, we have seen the random access. Now, in next lecture, we are going to see the control access techniques. What is reservation? What is polling? What is token passing? In detail, we are going to see it. So for any questions or feedback, you can post it to my email address, and you have to submit the assignment to my this email address, which is shown on your screen. So thank you very much, students. Thank you very much.